So parametric equations basically is they're a curve, okay? A curve generated. Parametric equations, also known as plane curves. Plane curves. It's a curve generated. Boy, I'm having trouble. Okay. It's a plane generated by plotting come on, you can do it. I'm like my brain is not warmed up to my hand or something. By plotting two ordered pairs x of t and y of t. Okay, and so of equations. So what's happening is you have one equation for x and one equation for y in terms of t. Okay, and t is called the parameter. Okay? It's called the parameter, and a lot of times it represents time. Okay, so parametric equations are used a lot of times for modeling like projectile motion and something like that. X is doing one thing, Y is doing something else. So if you like throw a baseball, right? That baseball is going up and down according to the rules of gravity, right? You know that, like 1/2 AT squared V sub 0 times T times 1/2 AT squared. Have you ever seen that formula in physics? That's what's controlling, that's the parameter, that's the vertical parameter. And then if you throw it at some angle, it's going this way, right? So if you throw the baseball, it's kind of doing this and this at the same time. But over time, if I add those two things together, so if the baseball is trying to go this way with one component and going up and down with another component, if I add those two things together, right, it kind of ends up doing that, right? So it's got a vertical, we'll talk about that more specifically in a minute. But the vertical thing is making it go up and go down, and throw it at an angle or throw it straight across. It's trying to go this way, so it's going up and down at the same time it's going across. You're going to generate a curve, okay? And it's doing that over a certain amount of time, called the parameter, okay? And when you combine those two things, you get what's called a plane curve in a parametric equation. Okay, so they have direction, right? They have direction. So when you graph a plane curve or a parametric equation like this one, it starts at one point and it ends up at another point, and that's controlled by the domain of t. Okay, and I'll show you what I mean in a second. Okay, we're going to do an example. Ready to do an example? Yeah. Okay. Can I move on? Okay. So sketch the plane curve. Example. Sketch curve for x equals 2t and y equals t squared plus 1 on negative 2, 5. So the way you do this by hand is by making a table. We're going to do one with your calculator. And let's make a table. Let's not use that. Let's take this. Let's take this. Let's take is. We'll make a table. Table. No arrow, solid, line. Here's a table. Beautiful. Well, not that good. It's a 1, 2, 3, not there, 4, 5. That's 7 boxes.
Yep.
Okay. So here I have t. Here I have x, and here I have y. And you can just go up. I mean, you could do different increments, but I'm gonna so this says t starts at -2, and it goes up to 5. So -2, -1, 0, 0, 1, 2, 3. Whoops, I guess I gotta keep going. One more box. 1, 4, and 5 up here. And then all you do to find the x and y values is you plug them into your respective x and y equation. Okay? So what should this be? Hello. 2 times -2. -4. -1. 0. 2. 4. 6. 8. 10. Where? Oh, you're in. -2. Do you guys all see where those numbers came from?
Yep.
I'm just plugging my t values into this equation. Okay? Now I'm going to take my t values and plug them into my y equation. Okay? What do I get in this case? 5. Everyone see where I got 5? -2 squared is +4 plus 1 makes 5. Whoops. Yeah, that's right. -1 squared is 1 plus 1 makes 2. 0 squared plus 1 makes 1. 2 squared plus 1 makes 5.
2. Usually 1.
What? Oh, 1, 2. Sorry. 2. 2 squared, that makes 5, right? 3 squared is 9, makes 10, right? 4 squared, 16, 17. 5 squared, 26. All right? So if I'm going to graph this thing, so you start by making a graph that kind of makes sense. So if I start my x's, so x, it appears, goes from -4 to 10. Y goes from 5 to 26. So I'm just going to kind of start like -4. So x and y, you graph the x and the y, you don't graph the 2. Let's say this is -4, -2. Let's make this 2. Let's make this 4. Make this 6, 8, 10. Looks like that's going to work, right? And then I'm going to kind of squish my scale here, otherwise it's not going to fit. Notice that all the y values are positive, so I'm going to get, let's count, what should I count by? 4s, maybe? Let's count by 4s. Let's count by 5s. 5, 10, 15, 20, 25. If I plot these points, all I do is I plot the x and y. -4, 5. There's that one. -2, 2. That's somewhere over here. 0, 1. That's like about here. 2, 2. Somewhere over here. 4, 5. That's like about here. 6, 10. What shape do you think I'm going to get? 8, 17. Way up here somewhere. 10, 26. Way up here somewhere. What shape does this appear to be? It's a parabola. Okay, so if I'm going like this. It's not a very good parabola. But notice that the direction is this way. Unlike a regular parabola, it does have a direction. Okay? And that's how you plot it by hand. You want to see how to do it with a calculator?
Yes, sir.
It's fun. You can do it with the calculator. So what? So I'm going to quote. Yes. So with your calculator, you have to first open up and okay, so first of all, you have to go to second clear, go to mode, and you have to be in this thing called parametric mode. Okay, see PAR right there. Parametric mode. Hit enter. You go mode par. Everyone there?
Yep.
Okay. Then, when you go to your y equals, notice that you have these funny looking things, okay? So in this case, x of t is 2t, 2t, and y of t is going to be t squared plus 1. T, notice when you hit the x, it comes out as a t now. T squared plus 1, okay? Now, with this is nicer when you go to window, okay? So I had this, it looks like it was a polar window or something. So I want my t minimum to go from -2 up to 5, right? So -2 up to 5. So you have to set the domain, Ricardo. You have to set the domain of your parameter, okay? T step. So what this controls is what the increments are that you're going up by. Okay, so I'm going to set this at, if I plugged in 1, I just get a bunch of dots. So I'm going to do like 0.1 and put that as my parameter. If you want to slow down or speed up your graph, if you want to speed it up, you make those numbers bigger. Then it's going to go up in bigger jumps, okay? If you want to slow it down, you make those numbers smaller, like 0.0. X-min, notice that my x value, so you should kind of check your range of x's or your domain of x's. It goes from -4 to 10. I'm going to go a little bit below that, like maybe -5 up to +12. Okay? And then I'm going to set, you have to set a window for your y's as well. I wouldn't worry about the scale. I keep that at 1. And the y's, notice there's no negative y, so I'm going to set my y from 0 up to, I went up to 26, so let's go up to like 30 or something like that. Okay? And then, if you hit graph, whoa, there it is. Okay? There, notice that it started here and it went this way. Okay?
Is there a reason it doesn't have the coordinate plane? Because
Uh,
of the Sonics project.
I think it's because of my conics project. I'd have to go second format, axes on, okay? Notice too, if I reset my window, so remember I said this thing controls how fast or slow it goes? If I change that to 0.01, okay, 0.01, I can see it going way slower, okay? So if I hit graph this time, see, there it goes down there, and it's going through and back up. And then you get that curve. Notice, yeah, got it? So isn't that cool? So that's parametric equations. So then we have something called eliminating the parameter. So say I have, so I don't like red. Eliminating the parameter. So say I have x equals t squared, and then I have y equals t squared plus 1. Go ahead, graph this. See it? Well, let's do it together. If I were to graph, on -3 to 3. Okay? So if I were to graph this, I'm just going to change my x and y equals to t squared, and t squared plus 1. Oh, I already have that. Don't I? T squared plus 1. And I want to change my window from -3, or for my domain of my parameter to this. And if I hit graph, I get this curve that looks, whoa, what happened?
It's because the window is still set. So you have to change the X.
Oh yeah. My window for that one. Oh yeah, because for this one I could have x is always going to be positive, right? X is always going to be positive. Y is going to be always positive, right? And wait. X min -5 Oh, I know. Oh, that's not what I wanted to do. I wanted this to be -1. Okay. -1.
Why is that one so different?
That's not what I got when I did this last night. It should curve, right? Oh!
It's the hot day.
Are you having problems with
Why are we running tight on the road?
Thank you.
I know I messed up. I'm sorry. So I'm back. This is how I want to have my graph. Okay? I'm sorry. I messed up. Okay? So when I plug this in, I want the first equation to be just t squared. I want the other equation to be t minus 1. Okay?
How did you get to that?
How did I get to this?
Yeah.
I just went to y equals.
Did you change your mode to parametric?
I did have to change my mode to parametric. Okay? And when I'm going to put my window in from x min, x is never going to be negative, right? Because if I plug in -3, I'm going to get a positive. If I plug in +3, I'm going to get positive. Y can go down. What's the lowest y is going to get in this case? -4. Okay. So I'm going to send my y min to, let's say, -5, and my y max to +5. Okay. Whoops. Y min to -5, and my y max to +5.
What did you set your X
I set my x max to 10, and the reason I did that because if I take 3 and plug it in here, I'm going to get out 9, right? So I want to be at least a little bit bigger than that. Okay. Then if I hit graph on this, notice what I get.
Whoa! Whoa!
I get a sideways parabola. Okay. Isn't that cool? So So this is not a function in terms of x, but it is a function in terms of y. So so the reason I did this is because I want to show you how to eliminate the parameter. To eliminate the parameter, you solve one of these equations for x or y. Okay. So so we already know that. Or for t, excuse me. So we already know that y is t minus 1. So what's t equal to?
Y plus 1.
T is equal to y plus 1. If I take y plus 1 and plug it into this equation, we get x is equal to y plus 1 quantity squared, okay? Which is the same as writing y plus 1 quantity squared is equal to x, right? Which is a sideways parabola with the vertex where? This is what we learned yesterday, from the last second. Where's the vertex of this parabola? At 0, -1, right? It opens to the right, just like the one that I just showed. Okay? So to eliminate the parabola, the parameter, you can solve for t and plug it into the other equation such that you have an equation only with x and y. Okay? Now this has a restriction on it. This only goes from -3 to 3, and it goes in this direction. Okay? So, but you can find out what those restrictions are by plugging in -3 in for t. I get out 9, and -9, right? So. X only goes from 0 to 9. Let's not worry about restricting so this is when I eliminate the parameter, this is the equation. Okay? All right, moving on. There's a harder one, but I'll let you deal with that for homework. Okay? And then going backwards. Whoops. So this is finding a set of parametric equations from a regular equation. So if I have y equals x squared plus 1, and I want to turn this into a set of parametric equations. There's infinitely many parametric equations that I could turn this into. I could let x be equal to t. If x is equal to t, then what's y equal to? T squared plus 1. Okay? That's one set of parametric equations that would generate this parabola.
Oh, so it's like,
Yep.
there's thousands.
There's thousands of them. Say I let x squared equals t, right? Say I let x squared equals t, then what would y be equal to?
T plus
Y would be t plus 1. If x squared is equal to t, that means that x is equal to the square root of t, right? So I could let, what's t not 2? I could let x be the square root of t, right? If x is the square root of t, then y is t plus 1. Yeah? So that's another set of parametric equations, this one and this one. Oh, look, a figure eight that I could have used. Anything else I want to try in there? You could let x equal t squared plus 1. Could I do that? Let x squared. I get, so say, for instance, on this one, let let t equal x,
Squared plus 1.
let t equal x minus 1, for instance, okay? Let t equal x minus 1, that means that x would be equal to what? T plus 1. And then to find y, I would take t plus 1 and plug it in there. So if x is t plus 1, then y is t plus 1 squared plus 1, which would be y equals t squared plus 2t plus 2, right? So if I plugged in this set of parametric equations, it should give you this parabola right there. Do you believe me? Or do you want me to do it? You can believe me, okay? So, last thing, you can graph a circle or an ellipse. Parametric equations are very convenient for graphing circles, okay? Graph a circle using parametric equations. So say I have, and the way you can do that is saying x is equal to 2 sine t, and y is equal to 2 cosine t. Just think about it a little bit, okay? This is a little review of trigonometry here, but I know you guys want to forget all about that, but if I have t, say I plug in 0, I plugged in like pi over 2 and pi. I just want to show you, and this is x, and this is y. Does anyone remember what the sine of 0 is? What's the sine of 0?
0.
0. What's the sine of pi over 2?
You did it.
What's the sine of pi over 2? 1. What's the sine of pi? 0. Okay, remember that? Well, except this is being multiplied by 2, so over here I'm going to get a 2 times the sine of pi over 2. What's the cosine of 0? 1, and 1 times 2 is 2. What's the cosine of 0? 0. What's the cosine of pi? -1. And so here I'm going to get a -2. So in graphing these points, I'm going to go, my first point is going to be 0, 2. My next point is going to be 2, 0. My next point is going to be 0, -2. And I would guess that when I got back to 3 pi over 2, I would have sine of 3 pi over 2 is -1. That gives me -2. And the cosine of 3 pi over 2 is 0. So I get this point right here. And so this curve is going to start here and generate around this way.
That's a circle, not an ellipse.
That would be a circle. I'll show you. Okay? So let me go to your calculator. I'm going to go mode. Okay? First of all, you got to make sure you're in radian mode. Radian mode. Right? I'm going to set up my window so that it will fit my graph. I'm going to go from 0 to 2 pi because I want to go once around this circle. Second, 2 pi. Okay? I'm going to set my increments to I'm going to set it to 0.1 so it goes a little bit. I'll set it to 0.05. 0.05. Whoops. 0.05. And then my x min. So notice that the x values go from 0 to -2. So I'm going to set that at -3. I'm going to set my positive x to 3. I'm going to set my y min, just like the x min, -3 to +3. Okay? And then I'm going to hit graph. What happened?
You didn't put in the equation.
Oh, 2 sine t, okay, and 2 cosine t, okay, and then if I hit graph, notice that I get, now, I know, baby. The reason that looks like an ellipse and not like a circle is because this scale is distorted, right? This 1 unit is not the same as the 1 unit there. If I go zoom and I go to square, that gives you a square viewing window. Then I get my circle. Okay? Whoa. Isn't that cool? How do you think I could change this into an ellipse? How do you think I could change that into an ellipse? Go ahead, Trent.
Change it.
Right. Put a different number in front of one of these, right? So if I were to change this, for instance, like Trent said, change that to a 3, now I hit graph. Now it stretches out to 3 on that. Unfortunately, for your conics project, everything has to be in y equals. It can't be in parametric because then everything else would have to be in parametric, and it doesn't really work with the whole window you set up and all that kind of stuff.
So
Yes,
is
ma'am.
that whole thing with the needing to have a square window, is that going to impact our clinics project?
No, because that window that I give you, that I set up, that makes it fit inside that. Because I set up, my window that I set up when I just did that was not a square window, right? So
Okay, so the window that we're using for
Right,
the contract.
right. Okay. I just want to talk about this. I'm not going to do a problem, but the very last thing that you're going to see for projectile motion can be modeled by these two, this pair of parametric equations. X equals v sub 0 cosine of t, cosine v sub 0 cosine theta t, and y of t, okay, is equal to h plus v sub 0 sine theta t minus 16 t squared. So there's one problem at the end of a baseball being launched. So theta is kind of the launch angle, right? So if you were to throw a baseball from a given height, theta is this angle right here. Who knows what h is? This is like really h sub 0. What's h sub 0? It's a starting height, okay? This is the start height. Start height. This is the initial velocity in both cases. Initial velocity, and same thing over here. It's the same initial velocity in both places. What is this accounting for right here? What's 16 t squared? Anyone know what that is from physics? You don't know.
What are you talking about?
That's the deceleration due to gravity. So this is like your vertical component. This is your horizontal component. So if you threw a ball up with initial velocity from a given height, if you threw it straight up from initial height, it's going to go up, and then it's going to slow down, and then it's going to come down, right? And this thing is pulling it down, right? If there were no gravity, it would just keep going forever and ever and ever, right? But this gravity is pulling it down at the rate of 32 feet per second squared, okay? But that's divided by 2 when you get to the formula, okay? So this is gravity, and this is your x component. So this is saying the ball is trying to go this way. This is saying the ball is trying to go up this way, and the result of that over time is that it's going to go up to a maximum, and then it's going to go down. So the last problem on your homework asks you to model that. with that parametric equation by plugging in some numbers. Okay, and that's all I have to teach you today. Okay, and hopefully you'll get it. Good stuff. Pause.